So we'll discuss the solution to this test paper. So the first three questions are comprehension based. So here the circuit is given, and you have to find what is the current through the cell. So whenever you find some wire which is connected directly, then you can say the potential of these 2 points are going to be the same, which means they are going to act like they are the same potential. So redrawing this diagram. So if this point is A, then, or let me just give some new name. So if this point is X, then this will also be X, same potential X. So potential of all these points are equal because they are connected by wire. So we can give a same name for that. So positive terminal of the battery is connected to this X, and negative terminal, let it be connected to some Y. Then this will also be at same potential Y, and this will also be at same potential Y. So you can see now all these points are at potential X. So only point which is left is some new point. This will not be at the same potential as X or Y because in between there is a resistor. Some potential will drop across the resistor. This will be some new point Y. Now redrawing this circuit by connecting the battery between point X and point Y. Let's try to draw all the resistors one by one. So all these are same points. They are at the same potential X. So this resistor now is between point X and point Z, which means we need some other point in between. So first we'll draw this 30 ohm resistor between X and Z. So this is done. Second, we'll draw this 15 ohm resistor. That is also between X and Z. So one more resistor is connected between X and Z. Then if you see this, or we can draw this first. So 10 ohm resistor is connected between Z and Y. One end is connected to Z, other end is connected to Y. So there is a 10 ohm resistor between. So this is also done. And then last one resistor between X and Y. So apart from this, we also have one resistor directly between X to Y. So this is the equivalent circuit diagram, and that value is 20 ohms. This is the equivalent circuit diagram for. Now we can combine these two in series. Sorry, these two are in parallel in series with 10. So 15 and 30 in parallel. So this will become 2 by 1 by 15 plus 1 by 30. So you can write this as 3 by 30. So these two in parallel will give you 10 ohms. So we can replace that with one single resistor 10 ohms. So between X and Z, between Z and Y, and between, so this is also 10, this is also 10, this is 20. So now immediately we can write the total resistance across the cell is 10 and 10 in series 20, and then 20 and 20 in parallel will give you half of the 10. So the total resistance across the battery is 10 ohms, and the battery voltage is given as 200 volts. So current drawn from the cell will be equal to battery voltage divided by total resistance, which is 20 amperes. That will be the answer for the first question. Second part, they're asking current in branch EF, which means 10 ohms. this 10 ohms. Now that is between Z and Y. So this 10 ohm between Z and Y. So this is the current they're asking, EF. That is here. So you can now say current in this branch will be equal to, so total resistance of this branch is 20 ohms, and this is connected across the two terminals of the battery, 200 volts. So this current I2 will now be equal to battery voltage divided by total resistance of the branch, 20 ohms, which is 10 ampere. And the third part is current in the branch AB. So current in the branch AB means they are talking about this branch. Now that branch is over here. Now for this, we have to find current in individual resistors. First, we have to go backwards. So this current, we have got it as I2 is 10 ampere. So which means here 10 ampere is going. Same way above branch also 10 ampere will go. Now go one step back. Between Z to Y, 10 ampere is going. So which means from here also 10 ampere should have come. And that got split into two parts. Say I2 and I3. So whatever current we got in this branch, same is the current in this part. This is basically combination of 15 and 30. That is what converted to 10. So 10 ampere is total current through the combination. The 10 ampere will split into some part will go here, remaining will go here. So you can find what is the potential drop across this. Potential drop across this will be equal to current into resistance. This delta V will be equal to I into R. So 10 into 10, 100 volts. So you can say same potential, that is the potential drop between X and Z. Here you can say both are connected between X and Z. So potential drop from here to here will be 100 volts. So immediately you can write I2 will be equal to 100 by 15. Potential drop across 15 ohms is, it's connected between X and Z divided by resistance. Same way, I3 will be equal to potential drop across this resistance is also 100 volts divided by resistance is 30. So 20 by 3, 10 by 3. Now we go one step back again. This 10 ohm is basically this one. In that current is 10 ampere. So now mark that here. This current is 10 ampere. This current is 15 ohms. I2 is 20 by 3. That 15 ohm is over here between X and Z. So in this current is 20 by 3. So immediately we can say what is the current in this branch, because total current drawn from the cell is 20 ampere. So 20 ampere is coming from the cell, out of which 20 by 3 is going here. Then remaining, can you say, will be the current in this branch. So we want current in branch AB only. So this will be I dash. Then the value of I dash will be equal to 20 minus 20 by 3. Which will be 40 by 3. So that is the answer for the third question. So now next, they're asking for location of the final image. So here, first you have to find image formed by the first lens. So apply the lens formula for the first lens. So for the first lens, object is at a distance of minus 20 centimeters. Focal length is plus 30 centimeters. Then use 1 by V minus 1 by U is equal to 1 by F. So 1 by so from here we'll get the value of V1 as 1 by 30 minus 1 by 20. So 2 by 60 minus 3 by 60. So V1 we get as minus 60 centimeters. So it means from the optical center, negative means image is actually formed here, which means after passing through the first lens, it will look as if it is coming from the first image is getting formed at 60 centimeters from the lens. Now for second lens, this will act like the object because rays are hitting the second lens. It looks like it's coming from here. Rays are hitting the second lens. It looks like it's coming from here. So image of the first lens will act like object for the second lens. So for L2, object distance will be equal to what is the object distance from this optical center? 30 plus 60. 90 will be the object distance. And focal length is minus 45 centimeters. So again apply the lens formula. So 1 by V2 is minus 2 by 90 minus 1 by 90. So we get V2 as minus 30. So it means this from here, it is formed at minus 30. That is basically 30 centimeter to the left of concave lens, which happens to be exactly coinciding with the optical center of this. So afterwards, it will look like it's coming from the okay, just ignore this part. So that will be the final answer. Then second part, concave mirror with focal length produces an image on the screen. Size of image is 4 times that of the object. Find the distance of object on the mirror. So in question number 5, so concave mirror produces an image on the screen. Since the image is formed on the screen, it's a real image. So concave mirror focal length is negative. So real image. And they are saying size of the image is 4 times that of the object. So we know real images are also inverted. So real and inverted image formed by a concave mirror. So it means magnification is definitely going to be inverted, means negative, minus 4. So magnification for a mirror is minus V by U. The minus V by U will be equal to minus 4. So we'll get V is equal to 4 times of U. And then we have focal length is also given. So mirror formula 1 by V plus 1 by U is equal to 1 by F. Instead of V, we can substitute with 1 by 4U. Focal length is given as minus 60 centimeters. So 1 plus 1 by 4. So you can take 1 by U common. It will be 1 by 4 plus 1. 1 plus 1 by 4 is 5 by 4. So you get the value of U as minus 75 centimeters. That will be the answer. And next is, so again 6 and 7 are comprehensions. In question number 6, they are saying voltmeter reading is 54 volt. So now this circuit, they are given the reading of the voltmeter is 54 volt. So the reading of the voltmeter is 54 volts. It means 54 volt has dropped here. Now this circuit, we can say whatever current is going through this 8 ohms, same current will go through 4 ohms. Which means you can say this 8 ohms and 4 ohms are in series within that branch, whichever order you arrange, it doesn't matter. So I can put that 8 and 4 together in series as 12 ohms. And then apart from that, this 30 ohms and this R ohms and this voltmeter is present. Now to understand this part, out of 90 volt battery, some voltage is dropping between here and here, means that is between point X and point Y. So all these points are at same potential. So they are in parallel, na? So potential drop between these two will be same as these two, between same as these two. So between X and Y, potential drop is 54. So here to here, the potential drop is 54 volts. Then immediately we can say battery supplies 90 volts, out of which some potential difference will be dropped here, remaining will be dropping here. Because when you go from battery now, from here to here, again here to here, total potential should be, battery will maintain 90 volt between this point and this point, positive terminal and negative terminal. So here to here, total we want potential difference of 90 volt. Here already 54 volt is coming. So what is the remaining potential drop here? And remaining potential drop will be 90 minus 54, or this will be 36 volts. Immediately we can find what is this current. This current will be equal to 36 volt by 12 ohms, 3 ampere. So only thing we did is this 8 and 4 we combined together as 12, because same current was flowing in both. So whatever current I1 is flowing through the meter, same current I1 will flow through 4, 8 both. So current in the ammeter reading will be 3 ampere. Second part is value of R. So if you see, this R was not at all required till now, because they gave other informations. So now we got I1 as 3 amperes. Then what will be I2? I2 will be equal to same 54 volt by 30 ohms, or this will be equal to 27 by 15, which is 9 by 5 amperes. Or we can say 1 point. Okay. So I2 is 9 by 5. Then remaining, so current entering this junction will be I1. Current leaving here is I2. Then remaining I3 will be I3. And whatever current is going there, same current will go here, because this is ideal voltmeter, infinite resistance. So immediately now we can get what is the current through the resistor. I1 minus I2. So 3 minus 9 by 5. So 6 by 5. Now we know current through this resistor. We have to find what is potential drop across the resistor. That is also given, because that is what is this 54 volt voltmeter reading. Then R will be equal to potential drop across the resistor divided by current through the resistor, I3. I3 is 6 by 5. 54 divided by 6 by 5. So 45 ohms. So seventh one. Then question number 8. Potential difference across 6 ohm resistor is asked. So here again you can see 9, 4, 5. So these two you can combine and write it as single resistor. So 3 and 6 in parallel, it will become 2 ohms. And then 40 volt. So all these are in series. So the current in this branch will be equal to 40 volt by this total resistance is 4 plus 2 plus 5 plus 9. 20 ohms or 2 ampere. So 2 ampere current means potential drop here will be I into R. So 2 into 4, 8 volts. Potential drop here will be 2 into 2, 4 volts. Potential drop here will be I into 5, 2 into 5, 10 volt. And potential drop here will be 2 into 9, 18 volts. If you add everything, 18, 28, 32 plus 8, 40. 40 volt is distributed in this manner. Now whatever is the potential drop between these 2 points, same will be the potential drop across the 6 ohm resistor. So this 4 volt is the potential drop across both 6 ohms as well as 3 ohms. Both are equal to 4 only because in parallel potential drop is same. That is the potential drop between these 2 points in the circuits. And then question number 9. So they are given a ray starting from point 2. First hits the concave mirror. Then it is hitting the plane mirror. And then finally the image is ray is coming here. It means the rays are going from here, hitting the mirror, and then again coming back here. Final image is formed here, they are saying. Now, if you extend this backwards, for this plane mirror, incident ray is coming in this direction. So we can draw one more ray now. Because if there was a ray which went in some other direction, no? Or we can just take a straight ray. So that also would have gone on to meet here, and finally it will also intersect here. So for this plane mirror, so first reflection is happening on the concave mirror. So it means first you have to focus on the concave mirror. Wherever the rays are meeting, that will be the image formation. The image of the concave mirror, I or I1, that will now act like object for the plane mirror because we put a plane mirror in between. And then because of it, the ray is bending and now going back. So instead of going this side, it gets reflected from the mirror and goes this. So it means we know for plane mirror, the object distance will be equal to image distance. It means if the virtual object rays are going to meet at this much distance, then after interfering, they'll meet here. So the plane mirror part we can solve first. And then now we can go for the convex mirror. So for convex mirror, this is X, so concave mirror, this is X. And this distance is anyway 100. So for concave mirror, So this distance will be equal to 100 minus x. So this will be the object for the concave mirror. And this will be the image for the concave mirror. So object distance will be equal to minus of 100 minus x. Image distance will be equal to minus of 100 plus x. Because object is coming from a distance of 100 minus x. Image is formed here, 100 plus x. And then they are given focal length is 48 centimeters. So using mirror formula, 1 by u plus 1 by v is equal to 1 by minus 45. Cancelling 1 by 48 everywhere. 1 by 100 minus x plus 1 by 100 plus x. Solving this equation, we'll get the value of x. So 100 plus x plus 100 minus x, 200 is equal to 100 square minus x square by 48. 9600 is equal to, so x square will be equal to 10,000 minus 9,600, which is 400. So x will be equal to 20. So distance of O from the pole means that is 100 minus x. The answer will be 80. Question number 10. Here they are saying image formed by the concave mirror and the plane mirror is coinciding. And focal length of the mirror is 16 centimeters. So first let's find image of the concave mirror. So for concave mirror, object distance will be minus 80 centimeters. So 1 by v plus 1 by u is equal to 1 by f. Focal length of concave mirror is given as 16. So 1 by v is 1 by 80 minus 1 by 16. So 1 minus 5 divided by 80 minus 4 by 80. Or we get the value of Vs minus 20 centimeters, which means image is formed at 20 centimeters from the. Now they are saying image formed by the plane mirror is also coinciding with the image of the concave mirror. Now we know plane mirror property, if this is object distance is x, then image distance will be x. So x plus 20 should be equal to 80. So 2x plus 20 should be equal to 80. We get the value of x as 30. They are asking distance between two mirror M1 and M2. So the answer will be x plus 20, which is 50 centimeters. In question number 11, person suffering from hypermetropia has a near point of 2.5. What is the power of corrective lens required? So for a person suffering from myopia, hypermetropia, the minimum distance he can see is 2.5 meters. So, but obviously for a normal person, the minimum distance is 25 centimeters. So for a normal person, if the rays, this eye lens, So the normal person, if the ray is coming from 25 centimeters, after crossing through the corrective lens, it should make it look like it's coming from what is the minimum distance the eye can see. The minimum distance the eye can see is 2.5 meters. So this is the near point of the person. So for this lens, object is at this. After that, then eye can automatically convert this rays and make the image form on the retina. So for the corrective lens, UV equal to -25, V equal to -250. Applying, we get the value of focal length as 1 by V minus 1 by U. -1 plus 10 by 250. So focal length will be equal to 250 by 9. So we're asking for the power in diopter. Power is 1 by focal length. So 1 by 250 by 9 divided by 100. So 90 by 25 diopter. It is 18 by 5 diopter. Question number 12. Object is kept at 10 centimeter from the focus. So here it's given the 10 centimeter from the focus. So this is 10 centimeters. Focal length is 20 centimeters. So U will be equal to -30. And since focal length is equal to -20 concave lens, they're asking height of the object is given. You have to find height of the image. So using lens formula, 1 by V minus 1 by U is equal to 1 by F. We get the value of PS minus 2 by 60 minus 3 by 60. So minus 5 by 60. We get the value of VS minus 12. And then magnification is height of image by height of object. That is equal to V by U. So minus 12 by minus 30. So this is 2 by 5. Height of the object is 10 millimeter. So 20 by 5, or height of image will be 4 millimeter. So 3 lenses are kept with some power. So equivalent power will be equal to P1 plus P2 plus P3, 8 plus 3 minus 2, 9 diopter. Then equivalent focal length will be equal to 1 by 9 meters, or 100 by 9 centimeters. But object is kept at 10 centimeters. So U equal to -10. So replacing all 3 lenses with single lens, whose equivalent focal length is 100 by 9. Now they're asking only nature of the image. So equivalent focal length is 100 by 9 means this value is approximately 11.1 centimeters. So object is kept at, so and it is positive means effectively it's acting like a converging convex lens of focal length 11 centimeter. Object is kept less than focus, then image will definitely be virtual and magnified. Even by applying, for second part we need the lens distance of the image. Even by applying lens formula, 1 by V minus 1 by U is equal to 1 by F 100 by 9. So 1 by V will be equal to 9 by 100 minus 10 by 100. So V equal to minus 100. So U is also negative, V is also negative, V by U is positive, and it's a virtual image. So we get the distance of the image is 100. So in this question, they are saying initial ray is parallel to mirror M1. So it means this and this are parallel to each other. So it means these two angles are corresponding angles. This is also 75. Now for a ray, plane mirror, incident ray, reflected ray. Incident ray also will make 75 with the mirror. Reflected ray also will make same angle. So angle of these two will make same angle with the mirror. So this is also 75. Now we have a triangle. So if these two are 75, 75, 150, then the third angle has to be 30 degrees. Now again for this mirror, this is the incident ray, reflected ray. So I reflected ray with mirror, incident ray with mirror, both should be equal. So theta is equal to 30 degrees. So in this question, they're asking bulbs with voltage rating and power rating is given. So we can find what is the resistance of each bulb. If only order we need, so here all three have same voltage rating. So here 50 volt will drop across this. So definitely power in this will be equal to, if 50 volt is dropping across B3, then definitely power will be 10 watt. Whereas here V1 plus V2 will be equal to 50 volts. So this voltage also less than 50, this voltage also less than 50. So because of this, power of one voltage across the bulb one is less than 50 volt means output will be less than 10. This voltage is less than 50 means output will be again less than 20. But now P1 and P2 are in series. So series means current through bulb 1 will be equal to current through bulb 2. Then immediately we can say if current is same, then power dissipated, we can use the formula I square R. Whichever has more resistance, that will have more power. Now resistance is, power rating is voltage rating whole square divided by resistance. So resistance is power V naught square by P naught. Voltage rating whole square by 10. So first bulb, this will be 250 ohms. Same will be the value for both B1 and B3. Whereas R2 is 50 square by 20. So I can say voltage rating is same, but power rating of 2 is more. So R2 is less than R1. So we know R2 is less than R1. So comparing these values between bulb 1 and bulb 2, current is same. So power will be more wherever more resistance. So R1 has more resistance means power dissipated in 1 will be greater than 2. So P1 greater than P2. That is the conclusion. And we are saying P1 itself is less than 10. Then P2 will also be definitely less than 10. Less than 10 is also less than 20. So now P3 is 10 watts, P1 is less than 10, and P2 is even lesser. So power output in P3 is maximum. Then comes P1, then comes P2. B will be the correct answer. Exact power dissipated in B2 if you want to find. For that we need values. So resistance of R2 will be, resistance of second bulb will be 50 square divided by 20. So 125 ohms. So current through this branch I naught will be equal to voltage supplied by the source divided by total resistance of the branch R1 plus R2. 50 divided by 250 plus 125. Now if you want to find power dissipated in this bulb, that will be equal to I naught square into resistance of bulb 2. So P2 will be equal to I naught square into R2. So 50 by denominator you can write it as 125 into 3, 375. So 125 into 3, the whole square times R2 is also 125. So that one of the 125s gets cancelled. So 50 square divided by 125 into 3 square. So again 20 by 9 watts will be the power dissipated in P2. So in 18 questions, incident ray appears to go and meet at 30. So then this will act like the object. So U will be equal to plus 30 now because it's a virtual object, and from the optical center, we are going in the same direction as that of the incident rays. So positive. Then 1 by V minus 1 by U is equal to 1 by F. So from here we'll get the value of V as 2 by 30 plus 1 by 30. So it will be equal to plus 10 centimeters. The answer for this is 18, this B. So 19th and 20th, we need to find what is the total resistance of the circuit first. So for finding resistance of the circuit, you have to identify which two resistors can be combined first. These two are definitely not in series or parallel, because parallel means one end is connected, other end is not connected. They are not same. In between you have something else. So potential drop here and here is not equal. So identify where, so starting point, nothing can be combined. Check the ending point. Definitely these two are connected together. Whatever current goes here, same current will go here. So the 6 and 2 are in series. So we can replace that with both put together. 6 and 2 in series will be 8 ohms. Then this 8 and ohm, 8 is in parallel. Then 8 and 8 in parallel together, we can write all this 4 ohms. Then this 4 and 2 will be in series, or maybe I'll just write this in. So 8 and 8 is in parallel. That will be 4 ohms. Apart from that, 6 and 24. So 6, 24, 3, 2. Now here 4 and 2 are in series. So we can combine them as 6 ohms. This is the method for combining this circuit. So these two together will be 6 ohms. And then 6 and 3 in parallel will give you 2 ohms. And then 6 and 2 is in series. It will give you 8 ohms, and 8 and 24 in parallel. That will be 6 ohms again. So finally it is 8 and 24 means 3 by 24 plus 1 by 24, 4 by 24, that is 6 ohms. Yeah. The answer for this is C. Then they're asking current through the 3 ohms. So current through this will be 80 by 6 or 40 by 3. Now out of that 40 by 3, again you can write 80 volts. Directly we can find what is this current, because 80 volt is across 8 ohm resistors. So I1 will be equal to 80 volt by 8 ohms, which is 10 amperes. So this I1 will be 10 amperes, but they're asking you to find the current through 3 ohms. So this current is I1, which is 10 amperes. Now that I1 will split into, here we have 3 ohms, here we have 6 ohms. So immediately we can say these two put together is 6 ohms. So how much will be the current through I2? So I2 will be equal to what ratio it's going to split? Current entering the junction into the other resistor divided by sum of two resistors. So 2/3 of that I1 will go here. Remaining 1/3 will go here. So answer will be 2 by 3 into 10, or 20 by 3 will be the correct answer.